Welcome to Optimizing Unity Game Performance, Profiling Deep Dive. In this video, I'll guide you through the process of profiling your Unity games to achieve smoother gameplay. This tutorial is perfect for beginners and those looking to reinforce their skills using the Unity 3D engine and Visual Studio. This tutorial is perfect for beginners and those looking to reinforce their skills using the Unity 3D engine and Visual Studio. We will cover essential techniques to make your games run more efficiently. Why is profiling important? It allows you to identify performance bottlenecks early in development, saving you significant time and preventing frustration later. By catching issues early, you can avoid costly rework down the line. We'll show you how to find and fix issues related to CPU, GPU, and memory usage. Understanding these core components is crucial for effective optimization. Pro tip: always profile your game on hardware that closely matches your target audience's devices. This will give you a more accurate representation of the performance your players will experience, ensuring your optimizations are relevant. First, ensure you have Unity 2022 or a later version and Visual Studio 2022 installed. These versions offer the latest profiling tools and features, providing you with the most up-to-date capabilities for performance analysis. Open Unity Hub and create a new 3D project. This will serve as our test environment for demonstrating profiling techniques. Name the project appropriately, perhaps something like Performance Profiling Demo. In Unity, configure Visual Studio as your preferred script editor by navigating to Edit, Preferences, External Tools. Select your Visual Studio version from the drop-down menu to ensure seamless integration between the two powerful tools. Make sure the Visual Studio Tools for Unity workload is installed through the Visual Studio installer. This provides essential integration between Unity and Visual Studio, enabling features like debugging and code completion specific to Unity projects. Pro tip: keep your Unity version updated to benefit from the latest performance improvements and profiling features. Regularly updating can also resolve compatibility issues and introduce new optimization tools. Let's create a simple scene with a cube and a basic script. This will help us demonstrate the profiling process from a clean slate. Add a cube to the scene by going to GameObject, 3D Object, Cube. Now, let's explore the Unity Profiler. Open the Profiler window by going to Window, Analysis, Profiler, or by pressing the convenient shortcut Ctrl+7. Hit the play button in the editor to begin profiling. The Profiler window displays real-time data, including CPU usage, GPU usage, rendering, memory, audio, and much more, giving you a comprehensive overview of your game's performance. The timeline at the bottom shows performance spikes. These spikes indicate potential problem areas that need investigation, highlighting moments where your game's performance might be dipping. Step 1. Record a profiling session by ensuring the record button is active. The profiler will capture data frame by frame, allowing for detailed analysis of performance over time. Step 2. Analyze the hierarchy view to identify time-consuming modules. The hierarchy sorts the data by the amount of time each module takes to execute, helping you pinpoint where resources are being spent. Pro tip: use Deep Profile mode for script-level details, but remember that this mode significantly slows down performance. Therefore, use it sparingly and only when necessary to diagnose specific, hard-to-find issues within your code. Focus on the CPU usage module. High scripts time indicates inefficient code that is consuming excessive CPU resources, suggesting areas where your C# scripts might need optimization. Step by step, select a frame with a significant spike and drill down into the player loop section. This provides a detailed breakdown of the CPU's activity during that specific frame, revealing the exact operations taking up time. A common issue is having heavy calculations or operations within the update method. The update method is called every single frame, so any intensive processing here can lead to significant performance bottlenecks and frame rate drops. Demo: add a loop in a script that performs a complex physics calculation every frame. Observe the resulting spike in the CPU profiler, clearly demonstrating the impact of unoptimized code in the update method. Optimize this by moving the physics calculation to fixed update if it relates to physics, as fixed update runs at a fixed rate independent of frame rate. Alternatively, cache the results if the calculation doesn't need to be performed every frame, reducing redundant computations. Pro tip: avoid using getComponent within the update method. Instead, cache these references in the start method for better performance, as repeatedly calling getComponent is an expensive operation that can quickly add up. Another tip: use profiler markers to tag custom code sections. This makes it easier to identify specific areas of your code within the profiler's timeline. Implement this by using profiler.beginSample and profiler.endSample around your custom logic. Switch to the GPU usage module. High draw calls often indicate too many materials or unbatched meshes. Draw calls are commands sent to the GPU to render objects, and excessive draw calls can overwhelm the GPU, leading to reduced frame rates. Step 1. Check the batches versus saved by batching statistics in the Unity Stats window. This will tell you how effectively your scene is being batched, which directly impacts GPU performance. Step 2. Enable dynamic batching in player settings by navigating to Edit, Project Settings, Player, Rendering. Dynamic batching combines small meshes that share the same material into a single draw call, reducing the GPU's workload. For static objects, use static batching. Mark objects as static in the inspector to enable static batching, which allows Unity to combine their meshes at build time, further reducing draw calls. Demo: place multiple cubes in the scene, each with a different material. Observe the significant increase in draw calls in the stats window. Then, combine the meshes or use a texture atlas to reduce the number of materials, and watch the draw calls decrease dramatically. Fix: combining meshes can be done manually in modeling software or using Unity's Combine Meshes function at runtime. Texture atlases combine multiple textures into one larger texture, reducing material count and thus draw calls. Pro tip: implement occlusion culling to hide objects that are not visible to the camera. This significantly reduces the number of objects the GPU needs to render. Set up occlusion culling via Window, Rendering, Occlusion Culling, and bake the occlusion data for your scene. In the Memory module, track allocated memory and reserved memory. Monitor garbage collection spikes, as these can cause noticeable frame rate stutters. Garbage collection is the process of reclaiming memory that is no longer in use, but frequent or large collections can interrupt gameplay. Step 1. Profile and play mode and intentionally allocate objects, such as creating new game objects or loading assets. Observe how these actions impact your allocated memory in the profiler. Step 2. Identify memory leaks in the snapshot. A memory leak occurs when memory is allocated but never released, leading to increased memory usage over time and eventually degrading performance. Optimize. Use object pooling for frequently created and destroyed items. Object pooling reuses existing objects instead of constantly allocating new ones, significantly reducing garbage collection overhead and improving performance. Pro tip: avoid using strings in hot paths, which are frequently executed code sections. Instead, use String Builder for string concatenation to minimize memory allocations. Monitor the profiler's GCalloc column in your scripts to identify exactly where garbage is being generated. For deeper debugging, integrate Visual Studio with Unity. Attach the Visual Studio debugger to your Unity project to step through code line by line and inspect variables, providing granular control over your debugging process. In Unity, go to Window Analysis, Profiler, and enable Deep Profile. While powerful for detailed script-level analysis, use this cautiously as it significantly impacts performance during profiling. In Visual Studio, open your scripts and set breakpoints. Breakpoints pause the execution of your code at specific lines, allowing you to inspect the program's state, variable values, and execution flow at that precise moment. Step by step, build and run your project from Unity. Then attach the debugger via Visual Studio's Debug Attach to Process menu. Select your Unity instance from the list of running processes to establish the connection. Use the Performance Profiler in Visual Studio for CPU sampling. This tool allows you to analyze call stacks and identify bottlenecks within your C# code, showing which functions are consuming the most CPU time. Pro tip: combine Unity Profiler data with Visual Studio's CPU usage tool for pinpoint accuracy. This powerful combination provides a comprehensive view of performance issues, allowing you to correlate in-game events with specific code execution. Here are some holistic tips to further optimize your Unity games, moving beyond just profiling to broader best practices. Profile and builds, not just in the editor. Use development builds for more accurate performance data, as the editor can introduce its own overhead that doesn't reflect the final game. Reduce the number of physics layers in your project. Each additional layer increases the complexity of collision calculations, potentially impacting CPU performance. Optimize shaders. Complex shaders with many passes or intricate calculations can be a significant drain on GPU performance, so aim for efficiency where possible. Avoid using coroutines for timing-critical tasks. While useful, coroutines can introduce overhead and are not always precise enough for operations requiring strict timing. Common pitfall: forgetting to disable the profiler in release builds. The profiler should only be enabled during development and debugging, as leaving it on in a shipped game will negatively impact performance. Pro tip: target 60 FPS for a smooth player experience. Use the frame debugger to identify rendering issues. Test your game on low-end devices early in development to ensure it performs adequately across a range of hardware, not just your powerful development machine. In this video, we covered setting up the Unity profiler, profiling CPU, GPU, and memory usage, integrating Visual Studio for deeper debugging, and essential optimization tips to enhance your game's performance. Practice these techniques on your own projects, starting with simple scenes to build your understanding. Remember, consistent profiling is key to maintaining optimal performance throughout your game's development lifecycle. For more in-depth information and advanced topics, consult the official Unity documentation. Thanks for watching this deep dive into Unity game performance profiling. Pro tip: regular profiling ensures your games run smoothly across a variety of devices and provides a better player experience, leading to higher player satisfaction and retention.